All right, welcome to today's explainer. Today, we're tracking the absolutely fascinating journey of a sand dune, from its very first grains coming together on the beach, all the way to its massive evolution deep inland. If you've ever looked at a towering hill of coastal sand and wondered exactly how nature managed to pull that off, you're in the right place. Let's get into it.
Okay, let's dive right in. We're splitting this journey into two main parts. First, how sand dunes actually form, and second, sand dune succession.
Part 1. How sand dunes form.
So, how does a massive hill of sand just appear? Well, it all starts with the wind. The wind acts as the engine here, picking up loose sediment and pushing it right up the beach. Eventually, all that traveling sand hits a snag, an obstacle on the ground, like some driftwood or a rock. The heavier grains stop and pile up against this obstacle to form a tiny ridge, while the lighter particles just blow over the top and settle on the other side. Now, the wind keeps howling, right? So on that windward side, the sand piles up higher and higher until it forms a sharp peak or crest. But here's the catch. It can't just build straight up to the sky forever. Eventually, that pile gets way too steep. It becomes totally unstable, the crest literally collapses under its own weight, and all those smaller sand particles tumble down the sheltered backside of the dune. Now, this is where it gets really precise. 30. When that unstable crest collapses, the sand doesn't just flatten out completely into a puddle. It slides down the back of the dune until it hits a magic number, a perfectly stable angle of exactly 30 degrees. The second it hits that 30-degree mark, boom, the sand locks into place and stops sliding. And that's the real secret here. Once it hits that stable 30-degree angle, the cycle just repeats itself over and over. The wind brings more sand, the crest builds up again, it gets too steep, collapses, hits 30 degrees, and stabilizes. This relentless, repetitive loop is exactly how these massive dunes slowly inch their way up the beach.
Which brings us seamlessly to Part 2. Sand dune succession.
Now, sand dune succession is basically just the geographical term for how these dunes and the plant life on them dramatically change as you travel inland away from the water. We're not just looking at piles of barren sand anymore. We're looking at a living, evolving ecosystem. The contrast you see as you walk inland is honestly wild. Down near the water, you have what we call embryo dunes. These are the babies, just a few meters high, totally exposed, bright yellow sand. Basically, exactly what you picture when you think of a beach. But as you move furthest inland, you hit the mature dunes. These things are absolute giants, reaching up to 15 meters high. And because they've been completely taken over by vegetation over time, you barely even see the sand. They look a lot more gray than yellow. So you might be wondering, how exactly does a giant hill of loose sand grow 15 meters tall without just blowing away in a heavy storm? Well, it's all about the plants. Plants like marram grass are the true architects of this environment. Marram grass shoots these incredibly long, tough roots deep down into the dune. It essentially acts like rebar in concrete, binding all that loose sand tightly together. Plus, it grows incredibly fast, which really accelerates that binding process. That massive, invisible root network is the only reason these towering 15-meter dunes can even exist. But the landscape isn't just an endless series of rolling hills. If you look closely between those lines of dunes, you'll spot a unique feature called a slack. A slack is essentially a deep trough or valley right in the sand, and it's created by the wind acting like a giant invisible shovel, scooping out sediment from the sheltered backside of one line of dunes and the windward front side of the very next line. And the wind can dig surprisingly deep. In fact, it can carve out so much sand from a slack that the bottom actually hits the local water table. When that happens, groundwater seeps right up through the sand, and you get these totally unexpected salty ponds forming right there in the middle of a dry dune system.
It's just a beautifully interconnected system, isn't it? From a single gust of wind pushing grains of sand on the beach, to the deep roots of marram grass anchoring massive hills, to salty ponds hiding between the ridges. Which leaves us with the final thought to ponder. Without the constant force of the wind to move the sand, or the quiet power of those roots to hold it all together, would these towering, complex ecosystems exist at all? I hope this explainer gave you a whole new appreciation for the beach. Thanks so much for exploring this with me today.